is managing to stay safe and well in these rather challenging times. I'd like to thank Stefan for his technical presence, and also Emily and Angela at QD for helping to organise this webinar. We've estimated about 45 minutes for the webinar, with a structure that I will first make a short introduction to quantum design. My colleague Stefan will then take over to discuss present challenges in microthermography and highlight the latest technology developments from InfraTec. And towards the end, we should have sufficient time for any questions. The way we'd like to do questions, please, is should you have a question during the presentation, please write it in the question panel, and we will go through each in order at the end. Okay, we're about ready to get started, and we don't anticipate that there will be any technical hitches, but if any should occur, please bear with us, and if necessary, we will attempt to restart the webinar. So to begin, I hope that everyone can see my screen, and I will now give a brief introduction to quantum design. The local UK office is located in Leatherhead, which is on the southwest outskirts of London. In the UK, we have a specialised group of people in sales, marketing and service. We are part of a global organisation with a presence in 20 European countries, with multiple offices throughout Asia and North America, and with our ultimate parent company being Quantum Design International in San Diego, US. We're a hybrid manufacturer and distributor which came about by the merger of two companies, Quantum Design, a North American manufacturer of low temperature instruments for the measurement of magnetic and physical properties, and the second company being LOT, or LOT Oriole, a well-established distributor of scientific instrumentation throughout Europe. We've been in business for about 35 plus years and have a lot of highly experienced and knowledgeable colleagues on hand to help you with your work. This is a slide illustrating our global structure and explaining where the UK office sits within our European organisation and alongside our offices throughout Asia and the Americas. Alternatively, you can see that we have a presence across the continents and all around the globe. Focusing on Europe, you should now see a map of our presence across many European territories through a combination of our own offices, distributors and partnerships. As mentioned, as well as being a distributor, we are a manufacturer of equipment for the measurement and characterization of fundamental properties of materials at low temperature or high magnetic fields. Two of our flagship products are the MPMS, which is a squid-based vibrating sample magnetometer, and our PPMS, which is more suited to investigating bulk properties such as heat capacity, electron thermal transport, and other optical or magnetic properties. Also, some more universal products that we manufacture in San Diego, and our most recent systems include a range of helium liquefiers for the recovery or recycling of helium. Our newest product is the Uncoooled, which is a ultra-low vibration 1.7 Kelvin 7 Tesla magneto-optic cryostat designed for microscopy experiments. Then we come on to our broad portfolio of products that we distribute. As you can see, we cover many different applications with an offering of various cryostats, imaging cameras from the X-ray through infrared and even hyperspectral, some fairly niche products such as spectroscopic ellipsometers, and a range of products in complementary areas such as electron and X-ray microscopy, as well as a variety of optical and photon components. This next slide shows an overview of partners we work with here in the UK and Ireland. Hopefully you'll be familiar with some or all of these already, but if not, perhaps take a little time to browse through our webpage. As you can see, I've highlighted our partner InfraTec, who are a manufacturer of infrared cameras and thermography solutions headquartered in Dresden, Germany. And finally, from me, I'd like to ensure that you know that in the current situation, you can certainly still have access to our team at Quantum Design through video conferencing with our sales and service team and with our partners. This is typically via Microsoft Teams, which you do not need to have installed as long as you have access to computer audio or a webcam if you prefer. And for anyone who has not used this yet, it is very simple and we just have to send an invitation link. So should you have any questions after today's webinar, or you prefer a dedicated one-to-one follow-up with a member of our team, then just let us know and we would be happy to set this up for you. And here are our usual contact details, as well as our website, the address which should be at the top of your screen. You can follow us on the social media platforms of Twitter and LinkedIn to ensure you are up to date with our latest releases and information. For more detailed information, we also provide a newsletter which we send quarterly to our subscribers. So please let us know if you wish to receive a copy of this direct to your inbox. So that's my introduction complete, and I have the pleasure to hand over now to my colleague Stefan Kaiser, who will talk to you about the challenges and solutions when using thermographic cameras for microthermography. Thank you.
Okay, ladies and gentlemen, I need some seconds to start my presentation here. So my name is Stefan Kaiser, representing InfraTec today. InfraTec, I work as a sales engineer in the international sales, so I'm responsible for clients in different sales areas around the world, for instance, the UK and Ireland. So that's why I participate here in this webinar today. And as a quick introduction into the topic, I want to present this little video here. What you will see is an LED, a multicolor LED, and it gives you a glimpse of today's content, what is possible with microthermography systems. So you see here the LED in action, providing heat. Of course, the heat amount is very low at LED, but the systems are sensitive enough to figure it out. They have enough spatial resolution to really see the tiny details here. And this gives you an idea for the next, I think, 30 minutes or something like this. But the schedule will be the following. To begin with, I'd like to give you a brief, short introduction what InfraTec is, who we are, what we are doing, what we are concentrating on. Of course, a short definition what microthermography for standalone system means, at least for this presentation. And then we will run through our solutions, our product range for microthermography. This shall be mixed in with some examples and typical applications. Of course, it will be a lot of electronics examples, but I found some others too. So, and in the presentation, I also want to give you an idea of special solutions of InfraTec, for instance, the MicroScan feature, which can be helpful for microthermography. Some special lenses we have in our portfolio to really provide some benefits. And of course, to round up such a standalone system, there's accessory available to give you a nice user experience. So first of all, InfraTec, who we are. So we are really a company focused on infrared technology. We are still a founder and owner-based company located in Germany, in Saxony, in a nice Dresden, if one of you knows this city. Currently, approximately 230 employees, mainly here in the headquarters in Dresden, but we also have offices in the UK and in the US, for instance. And our focus is really on the infrared measurement and infrared sensor. That's why we have two business units. One is for infrared sensors, so little electronic components that detect infrared radiation. One quite interesting application is the detection of CO2 levels. So these days we are really concentrating on these sensors for CO2 concentration because they are used in the ventilators, and it's obvious why there is a high demand currently for these kind of products. But today we are talking about infrared cameras, and I'm a member of the infrared measurement division. So we are dealing with infrared measurement devices, cameras, to create a two-dimensional image of the samples of the measurement objects. And our solutions are not only cameras, but also turnkey solutions. So that means 24/7 products for various automation projects. But we want to provide also a full package. That means we add thermography training courses, thermographic services, thermographic software. So you can expect the full package from us as a supplier of technology, not only hardware, but also knowledge training. And we are small enough to act flexible to customer demands. So we have our own development here in Dresden, hardware and software development. So we are luckily able to hear your demands and then act properly. So what is InfraTec famous for? So we are concentrating on high resolution cameras. So what you will see here are our main brands of infrared measurement cameras. So on the one hand, you have a so-called microbolometer camera from the Viocam series, providing an XGA resolution, which is really a top for a radiometric camera. And on the other hand, you see here an example of a cooled infrared camera from our ImageIR series, the ImageIR 10300, providing native detector resolution larger than full HD, which is also the top end, the high end of the market currently. So you will not find anything with a higher resolution than this expect in the military, but this is a little bit often normal expectations. So to add to this cameras, of course, you need to have good software for analyzing. In general, radiometric cameras, measurement devices, you need to analyze these measurement values. So you have 300,000, 1 million measurement points. So this is necessary to analyze them, to do something with it. So we are facing this by a quite wide software range, analyzing software for Windows, but also an SDK for implementation in your own programming with a direct implementation, MATLAB, for instance, which is highly interesting for our clients and universities, but also LabVIEW and some special software products for reporting. So there's a lot to expect. And we develop these software tools again here in Dresden on our own. So this is something our development, our knowledge comes into this software that are necessary. So to round up what we deliver normally in our offers, it's not only the camera hardware, so camera body and lenses, but also third-party hardware, special hardware, for instance, like such a tripod here. We combine this with all the necessary equipment, with PC hardware, with software, also with training these days, more or less web-based. But once the situation gets a little bit better, we are happy to visit you again on site to provide training to your staff, to your colleagues. So we want to really provide a ready-to-go setup for you, make it easy to start, being productive, starting your research and development. So this is our goal, to be productive partner for you. So I want to jump in now into the topic. So what does microthermography mean for standalone systems? And before you will see what is possible today, what's the performance, I have to give a little bit of a background. I think this is obvious. We are talking about the infrared fraction of the light. So the relevant fraction is something between 2 and 14 micrometers. This is the fraction we use in microthermography, and which is what is also obvious, I think, is that the heat that's coming from an object is transferred into radiation, IR radiation, and we're measuring more or less the amount of radiation coming from the object and correlate this to a temperature. That's why the cameras are radiometric cameras. That means they are calibrated, which adds some work in how to set up such a camera, how to calibrate such a camera, that we can use them as radiometric measurement devices for contactless temperature measurement. What you need to know also is the general technology for infrared cameras. That means there are two general types of cameras. The so-called cooled IR cameras, they are based on photon detectors. These days they are cooled with Stirling engines, so no need to put in some liquid nitrogen or something like this. So absolutely safe to use. These cameras are the top end of the technology currently. So the best image quality is there, the best spatial resolution is there. They are capable of high-speed imaging, high-speed data acquisition. They are also capable of spectral sonography. So there are a lot of technical details making the life easy for you. But these systems, as long as they are so highly sophisticated, they require a solid budget. So for a couple of interesting applications, and so-called uncooled IR camera is sufficient. So there are there's no need to cool the detector at these cameras, so-called microbolometer cameras. They provide a decent amount of spatial resolution, so they are not so high frame rate. So 30 Hertz is a common frame rate for these cameras, but they are also available as mobile cameras. So it's more or less a multi-use of these cameras, and because of that, the budgets necessary are a little bit lower here. So for InfraTec, that means cooled IR cameras are in the brand name of ImageIR. You will hear this name a little bit more often in the next minutes. And then we have our VaryCam HD series representing these kind of microbolometer detectors. The other thing you have to know is, when you're thinking about your application, what's necessary, what kind of resolution you need, what kind of spatial resolution you need. You have to know these kind of cameras and what kind of lenses are available for them. So when you think about a microbolometer, you have to know that what you can expect is microscopic lens with a magnification of 1. So an MX1 is the top end of the resolution, representing some kind of 17 micrometer. And then you have standard lenses, 0.5 millirad of spatial resolution, corresponding to the 30 millimeter lens, for instance. If this is not sufficient, for instance, if you need smaller pixel sizes, then you have to consider a photon detector. That means an ImageIR, because only for these cameras there are microscopic lenses available providing more spatial resolution. For instance, an MX3 or an MX8. So we are talking then about an IFOV of 2 micrometer or 5 micrometer, something in this range. And if this is necessary, we clearly have to speak about such a photon detector, simply because of the available lenses for these different technologies. So we are close to the more or less clue what microthermography mean. So thermography in general is the contactless temperature measurement of an object with a camera or with a sensor in general. So we are speaking about micro. That means we are switching from more or less the standard scale to the microscopic scale. Our field of view shrinks down to the centimeter range. Our instantaneous field of view shrinks down to the micrometer range. And that's why we also talk about mid-wave systems here. Only only a few systems are available in long wave for these kind of applications. So it's really the microscopic scale with microscopic lenses, and that's why microthermography means a contactless temperature measurement of microscale objects, but also microscale details. So often the object is rather large, such as a PCB board, for instance, but you want to focus on the tiny details, and that's why if customer starts to talk about his demands and his objects and what he wants to do, I ask them quite commonly, what is the size of your details, what you really want to resolve, and how many pixels you need. And that's more or less the starting point for microthermography, not the entire object itself, but we are focusing on the details here. But keep in mind, microthermography, contactless temperature measurements in these microscopic scales. So there are different approaches you can try to solve this. So for the standard scale, and reaches a little bit in the microscopic scale, is the lens setup with a standard lens with a so-called close-up lens on top. So these close-ups, they provide the possibility to lower the working distance to have a better spatial resolution. But the beauty of this is that you have a flexible setup. So you have your camera, you have your standard lens, you can do ordinary task with larger field of view, but then you add these attachments, these close-up lenses, and then you can glimpse a little bit into the microscopic scale. On the other hand, if you really want to commit yourself to one application, then there are these microscopic lenses, the microscopic tripods. So your entire setup is really committed to the task you want to solve. Maybe you have different microscopic lenses there to be a little bit flexible, but it's really what you want to do with these cameras. At this slide here, I want to add one information, especially for these cooled cameras you see here in these images. There are so-called close-up rings. These are little rings you put in between the camera body and the lens to adjust the working distance a little bit. But this is something we may have to speak in detail because they influence the optical performance. They may add vignetting and stuff like this. So there's a ton of flexibility, but there is also a little bit of talking necessary when you choose one of these setups at all. Of course, you can add a microscopic lens later on or add a standard lens later on. So it's obvious that lenses are interchangeable these days. To give you a little bit perspective and start with the first example, what does it mean? Yeah, standard lens, close up, and microscopic lenses. So imagine this PCB board here, and we want to focus on this region here a little bit. When you see this PCB board in the thermal with a standard lens, you notice, yeah, you have a good overview of the board. So the field of view matches the board pretty nicely, and you see, yeah, the heat distribution a little bit more in general. When you add a close-up lens, then you see, of course, the field of view shrinks a little bit down. On the other hand, the instantaneous field of view gets better, and some details start to appear that are not visible in the overall. And of course, you can add the microscopic lens. This is the first really microscopic approach here. And you notice from this detail here, this little resistor element here, the resolution gets really nice, but nonetheless you can top this, of course, if necessary, with an MX3. And yeah, again, the field of view shrinks down. the spatial resolution gets better and gets better. So we have here a VGA detector. That means 640 by 512 pixels are now concentrated in this little field of view. But as I told you, there's also an MX8 lens available with an instantaneous field of view of 2 micrometers, so 1 pixel here in this image represents 2 micrometer. So this is really the top end of resolution that is possible. And this is not only something for InfraTec in general, this limit here, but also a general thing, because it's hardly possible to resolve anything better than 2 micrometer, because the wavelength of the light you use, of the IR radiation, is more or less in the same scale. So it's in general hardly possible to resolve anything really better because of general physics. You can dig into this topic if you like, but you will come to the clue that on the market, the MX8 is top end, what you can expect. So to give you a little bit of an idea of product, so start with an ImageIR series. As I told you, these are these so-called cooled photon detectors, providing the top end of the market. So we develop these products here in Germany, in Dresden, in our headquarters, from scratch. So everything is in our experience, and we are doing this almost for 25 years now. And that's why you will find some interesting features here. These cameras are highly modular. That means they will be built on your demands, on what demands came from the application, based on different detectors available, based on different, for instance, frame rates requiring different data interfaces like 10 gig E or gig E. So we rely on standard interfaces to make the life easy for you, simply because of availability of these hardware suits. But there are also multiple ways to customize these products with spectral filters, with filter wheels, with high temperature calibrations, with interchangeable front modules. So there is a ton of technical things to add to these cameras. So, but they are really focusing on the high-end demands on the market. So in terms of resolution, in terms of high-speed data acquiring, in terms of image quality in general. So if you really are on the edge with your application, then it's clearly that you consider such a camera. And to give you a little bit of an overview here, as I said, the product portfolio is quite large. So the main products you have here as an overview, just to give you an idea of the native detector resolutions, the native speeds of these things, but also some ideas of features of InfraTec, like the MicroScan feature, like the binning feature, like things like Hisense. You are highly welcome to discuss these things with us afterwards. We develop these technologies to make the life easy, to really enjoy working with an IR camera, not thinking about how to use it, but to think about what the results are telling you about your processes, about your R&D. So I'm pretty sure that we will find the perfect solution for you based on our portfolio, and even for different budgets, there are different cameras that can be upgraded afterwards. Just an idea about the lenses. So there are multiple lenses, of course, available for these cameras. And what you see here is a little bit of a comparison between the ImageIR 8300, which is more or less the working horse of us, and the ImageIR 9400, which is one interesting product because it provides high speed and high resolution at the same time. And you see here typical lenses for these systems. And yeah, just to give you an idea what field of views you can expect, what field of view you can expect. But I also recommend you to browse our website for our field of view calculator. You will find all the models, all the lenses there, and you can easily type in your working distance or simply choose a lens, and then you get these kind of information, size of the field of view, size of the IFOV, and then you can play a little bit around, educate yourself. So it's a nice service that we provide straight on our website. As an example, I chose this one here. It's a fingerprint sensor of an iPhone. It's not the latest model, but it's quite of interesting to look directly through the cap actually. So the cover of the sensor is IR transparent, so we didn't remove it from the iPhone, so we just positioned the camera on top of it and then made these beautiful images. And the first image here is made with an MX1, so you have a pixel size of 10 micrometer here, but of course you can once digital zoom in to the details and how such a sensor looks in detail. But what is really astonishing is the comparison here between these two images. On the right hand side, you see clearly some more details. You see the clearance of the image quality here, and this is a little bit of a daily ordinary product. Opens your eyes to the possibilities of IR technology here. There's another example here. I'm not so familiar from which applications or which background you are talking, but imagine a milling process here. And of course, microthermography can be used for this kind of applications too. So what you see here is the edge of the tool, removing some material here, and this technology also can be used in the combination of high-speed data acquisition and good spatial resolution, as an example of the normal electronics, which is obvious. So the other camera series I talked about is the Viricam series. So these called microbellimeter cameras. They are also available with a quite large product range with different detector formats, with also a superb image quality for this kind of product. So when you compare these stats with other manufacturers, you will see that this is a really professional high-end product. Just to give you an idea about the performance here, these products are available as handheld cameras as well as stationary cameras. So of course you can put a handheld camera also on a tripod on a stand and use the camera as a multi-purpose. But for instance, if you have the idea only to use stationary cameras, then the XGA resolution of this camera is really unique in the market. But this product is also highly interesting for our clients in the industry because it provides a good protection degree of IP67. So it's a really robust camera. But as I said at the beginning, the lens is available only, in brackets, only reach down to 17 micrometers with a microscope of MX1. Simply because we are talking about long wave cameras here. So again, there is a limit of what is physical possible to resolve with a long wave camera compared to a mid-wave camera. Two other examples only to give you an idea of the performance. So on the right-hand side, there's a little animal, a spider, to add a little bit of idea to you is I had a client who wants to do some studies on bees, for instance, how they react to chemical products or chemicals that are put on the plants, on the fields, and he wants to investigate how these insects react with the body temperature, with the behavior, and this little spider here should represent this. So there are top applications also for these kind of cameras. So to go further on with some special solutions features of InfraTec, I want to talk about our MicroScan feature. This is something unique for InfraTec because it provides a technology to boost your resolution, your normal resolution you have from an FPA. So that means from a detector. And what we do, we have an active technology, so an active image shifter in these cameras that will shift the image a little bit in its relative position to the detector. And by this, you see here this little Siemens target on the bottom. We can resolve the image with 4 times the pixels because we're switching only by a half of a pixel. And when you do this not so slowly, but with a high speed shifting, with a high rotating filter wheel, then you can achieve a smooth image acquiring also. And as long as this is an active optomechanical process, you can switch it on and switch it off easily, so you can make more out of your detector, your performance. And how does it looks in in an example here? So based on an VGA detector, again 640 by 512 native detector pixels, you will see you have here some structures in the image, and with the normal detector you are barely able to see anything. So these lines are mixed in the lack of resolution. But if you turn on MicroScan, which is an instant turning on, so they don't need to warm up the camera pretty much. So instantly you press the button and then MicroScan is working. You see that you are able to resolve these elements again. And as a real example here, you have this PCB board again, PCB board with a standard resolution on top. You see this, you can see the pixels and get an idea about. And on the lower end, you see the same field of view with MicroScan. So the other advantage is that the field of view does not change, but you see that you scanned the image a little bit better. And when you compare these red lines that I have here in these images, you can see on the left-hand side is the standard resolution, and on the right-hand side is with microscanning. And you see the increase of pixels over this line gives you the possibility to boost your system, increase your resolution doing such kind of microscanning. This technology is also available for the biochem models, works on the same way here. So what we basically do, we shift the images and make 4 images in a row and then combine them. It looks more or less like this. And then the video is not playing, but here you can see that it is really an active optomechanical technology that can be turned on and turned off to give you the possibility to add resolution to your images. Another nice feature of our products for the ImageIR are microscopic lenses with a large working distance. So typically what you may imagine is a microscopic lens comes together with a short working distance. This can be challenging when you have a setup like this, when you want to do the measurements in a larger working distance, if you need this. And that's why we came up with microscopic lenses with a working distance of 200 millimeters, respectively 300 millimeter lens, working distance with 300 meter lens, and these are MX1. So you are able, by choosing these kind of lenses, to really make the most out of your existing setup, but being able then to do the measurement task. MX1, again, as a reminder, represents 10 micrometer, 15 micrometer pixel size. So this is sufficient for a lot of applications out there. PCB boards like this, but also on the chip level. It's high. It's common that we are asked for these kind of lenses. Another extension of the performance of these systems is the so-called SIL attachment. So SIL stands for solid immersion lens. This is something can be added to microscopic lens to increase the optical performance a little bit more. But such a SIL cone has to touch the surface of the object, so it's a little bit off the normal approach of a contactless temperature measurement, and also the surface of your object needs to be kind of planar, so as long as the cone needs to touch the object, but this is something kind of special than the typical users want to have contactless temperature measurement. When I give you a perspective, the main focus is here on the MX1 in absolute terms of customers choosing a setup. So at the end, if we have chosen the lens, the camera type, and everything, then it comes about making the package a little bit more smooth. So that's why we developed some kind of a motorized tripod, a motorized adjustment of the relative position of the camera to the measurement object. So then it's possible to really control this motorized axis with the same software you control the camera with, because you can adjust the height of the camera and then step through the field of depth maybe. And this can be extended also in a full kind of measurement chamber with an XYZ axis, also to catch the other two directions. What you see here is an example with a power supply we provided. In addition, there was a special remote for this kind of setup. So as I told you before, we have our own group of engineers to develop these kind of projects. So we are really open to hear your ideas, to discuss with you what's necessary to fulfill your demands, and then we will find the proper solution. Either it is simply a standalone camera and you integrate this in your existing setup, or you trying to find out what is possible, what InfraTec can provide, and then we will find a proper way to equip your laboratory, for instance. So that's the last slide of my presentation. I want to thank you for your attention and for joining us today. And maybe Ashley, you run through the questions and we will try to answer them directly.
Yeah, thank you very much, Stefan. So I'll take back over the floor now, and we should have time to answer any questions. I'll check what we have so far, but please could I ask anyone with a question to take a moment and type it into the question panel, and then Stefan and I will endeavour to answer it for you now. So we'll just wait a minute.
So maybe one info for you, if you're interested to have these slides to review, please come back to us directly. We will send you the slides as a PDF version. Feel free to contact us directly if you have any questions. So we know you're highly welcome to reach out to us.
Mm-hmm. So we've got a few questions coming in, Stefan. The first is, what's the range of pricing that we can expect for these types of systems?
So maybe this is a better question for you to answer, but maybe the rough expectation is for an ImageIR system, we are talking about higher 5-digit, lower 6-digit sums, and an uncooled system like this, we are talking about low 5-digit sums. So it really depends on the actual model. It depends on the lens setup. So when you imagine a customer choose multiple lenses, of course, this is a different game than one customer straightforward with one camera, one lens, a simple calibration. So it really depends, and you are highly welcome to discuss even your budget plans with us. We are used to projects lasting a little bit longer, which is obvious in the R&D, I think. So, Ashley, have I answered this correctly?
Yeah, for sure. I'm like, I do have obviously some a range of pricing in mind, but you've answered it already. So I think we'd be looking sort of, you know, as you say, realistically in the sort of 70 to 100 odd K pounds for those in pounds. And then obviously we have much higher specification systems as well, which would cost more, but they're slightly more specialist. Okay, so we have another question as well, which is, could you perhaps, Stefan, go back over SIL, please?
This little lens, so we will
sorry,
try. Yeah, this was this slide here.
Yes, and there's an extension question, which is benefits to and comparison with standard lenses.
So this is a little bit complex to explain. So what you have when we're talking about a radiation or heat distribution, then we have to think about how the heat comes from an object, and it's not so pointy, let's say it in that way. So if you imagine you have a resistor on a board that produces heat, and this heat not only comes from this resistor alone, but the heat will distribute into the board itself, and that's why your hotspot is a little bit larger maybe than the part itself, and that's why sometimes the theoretical resolution it gives you an idea how large the pixels are, but when it comes to resolving details, then it's a difference what the geometrical resolution is and what the size of your hotspot is. And this SEAL lens is helping you to put it in brackets here to increase the line resolution. So that's why this SEAL is made of germanium, and this has a different refraction index, this is the right word, compared to air, and that's why the wave or the light will be transported in a different way, and that's why it helps you to resolve the actual thermal event a little bit better. So maybe this gets a little bit more clear if you look at sample data, and the one who asked this question shall come back to us directly. So this is to explain this is a little bit more complex than doing this in 30 seconds here after this kind of webinar. So it boosts basically the optical performance a little bit further. To add one point, we have these kind of products in our demo pool. Also these kind of special attachments and accessories. So feel free to ask for a demo or even for a rental to really find out what is necessary. We have our own lab here in Dresden, so it's also possible that you send us a sample of your product if this is possible, and then we will do some comparisons of lenses, what the actual results are, and then we will find out together what's the solution for you.
Okay, thanks, Stefan. So we'll move on to the next question. So we have one which is it possible to integrate the camera into a reactor? And more specifically, how does it withstand environmental temperature, relative humidity, etc.? And could it be placed in, for example, a drying tunnel? Do you have any information on that?
Yeah. So this is a kind of common question. So you have to think about the environmental conditions of the camera. So basically, we are talking about a top end of. It would be better to have the camera below 40 degrees. Maximum is 50, something like this, of the actual camera temperature. So this quickly exceeds, or you quickly come to the clue that integration into the reactor is not possible. So then you have to think about what can we use an IR viewport, for instance, a kind of window. Sapphire, for instance, is a good material because it withstands temperature, it withstands mechanical load quite nicely, but luckily it's also transparent in the IR and the midwave especially. So the typical solution for these kind of questions is to implement an IR viewport into these chambers, and then to try to find the compromise between the size of this port and the lens and the working distance. This is something for microthermography. As I told you before, the working distance is sometimes an issue, and then these kind of microscopic lenses with the larger working distance are highly welcomed, because simply we have space to add the IR window into the measurement chamber or whatever. Hopefully this answered the question in the way expected.
Sorry, I'd muted whilst you were answering that question. So the next question I have is, what is required NETV for microthermography?
Excuse me, what is required?
Yes, so I think it's, yeah, approximate answer.
So what I understand this question that way. What is required when we want to choose a camera, existing camera? Basically, what is required? You have to give us an idea about the application in general, what you want to do, what kind of materials, and of course the optical demands. How large are the details? What is the expectation of the field of view? The other way to understand this question, what is necessary, maybe it was the first one with the budget.
Sorry,
so,
Stefan, I'm not sure whether I pronounced the question very well or you didn't hear me, but the question is, what is the required noise equivalent temperature difference for microthermography?
Also the NETD?
Yes, the NETD.
So we're talking about here the same the same region as for standard lenses. So you can expect NETDs way below 100 millikelvin. So not so sure how to answer this this correctly, though. There's no specific demand. NETD depends a little bit on the actual material itself, how good the emissivity is, on the temperature we face. If it's a cryo application, of course, then they will have lower radiation in general. Then it gets more critical. So, but these lenses are highly IR transparent, so the thermal resolution is quite nice. So almost the same as for standard lenses. No particular demand.
Sorry, I didn't mean to interrupt. There is a follow-up question actually there, which is how do we handle the different emissivity for the components on a PCB to ensure that we're making precise temperature measurements?
Yeah, so there are different approaches. First of all, this is the simplest advice. Think about really the regions of interest. So if you are not interested in the region with a poor emissivity, then it's simply no need to correct this. But if it is necessary, there are two ways of thinking about this. One, is it possible to change the product simply by coating it, maybe with some lacquer or even powders that normally produce a thin layer that not influences the heat distribution. The other thing is it's a little bit of an academic approach, but it's actually possible to make a pixel by pixel emissivity correction with a reference image. So example for a PCB board, if you are able to heat up your PCB board to a well-known temperature, for instance 50 degrees with a special oven or so, and then you make a reference image, then you can tell the software, yeah, I know that for all these pixels the temperature is the same and the temperature is 50 degrees. Then the software calculates back the emissivity values as a matrix, the same size than the actual image, and this emissivity matrix can be applied on the actual measurements, and then you have a pixel by pixel correction. But this requires a precise procedure of heating up your sample board for the reference image, but also have a good alignment of this reference image with your actual image. And of course, our software provide not only this pixel by pixel emissivity correction, but also different other mathematical approaches to do mathematical correction of the emissivity value. But if necessary, if possible, trying to change the part itself, it's the most easiest way to deal with these given physics.
So we have also a follow-up question to one of the previous ones about the environmental conditions. So in the case of window into the equipment, what are the relative humidity and temperature limits for the lens?
So if the camera is outside of the chamber, there's basically no influence of the atmosphere inside. When we talk about the ImageIR series, we have a decoupled optical path. So that means that the temperature of the lens will not influence the measurements in a way in two directions. Of course, the camera produces heat itself from the electronics built in. So the Stirling cooler, of course, it's kind of a cooling engine, needs to get away with the energy. So the lens is thermally decoupled from the camera. So, and the other way around, if the lens heats up, this shall not influence the camera in a way. What you should provide is humidity on the lens itself. So by changing the temperature rapidly, for instance, that you have just water on the condensation on the lens, because water is it's not transparent, so it acts as a damping. This you have to figure out. On the other hand, what we do at our calibration lab, we do actual 3 calibration curves. So that means 3 camera temperatures are calibrated. One calibration is done more or less at room temperature, 22 degrees, and then we will do one calibration with lower temperature of the camera and the lens, of course, of the whole system, and one with higher. And often, because of that, we know these calibration curves, then we can compensate changes. And of course, there are multiple temperature sensors in the cameras. One is near the lens, that we can estimate the temperature of the lens and use these information to ensure a high accuracy over different states of the camera during these measurements. But in general, the demands are not different from the general demands of the camera. So I do not recommend to heat up the lens more than the camera itself.
No. Okay, and we have one more new question, which is related to the SIL lens again. Is the transparency of the SIL lens made of germanium sufficient enough to image in the MWIR region?
Mm-hmm. So, as you see here, we're talking about an ImageIR. So we're talking about a mid-wave camera system, and of course, this germanium cone is also coated with an anti-reflection coating, and that's why it's suitable for applications in the mid-wave. So the answer is yes.
Excellent, and that brings us to the last of the questions that have been asked. So if anybody has any more questions, please ask them now. Otherwise, we'll start to wrap up the webinar. Thank you, Stefan. That was a very useful talk, and thanks everyone to joining in. It's always good to have so many attendees on a webinar like this. The video will be available, and our contact details are on screen now as Stefan's just displayed them. So should you have any follow-up questions or something that occurs to you, please take down at least our names, and then you can get in touch with us via the respective websites, email addresses, and telephone numbers, and we'd be very happy to speak with each of you. Okay, Stefan, if you have anything else to say?
No, but yeah, thank you again for your attention. I'm curious to hear your feedback. You're coming back to us with your applications, with your ideas, and then I'm looking forward to hear from you again. And then thanks, Ashley, for this nice organization, also to Quantum Design. And yeah, thanks everyone, and then have a good day, stay safe, and then bye-bye.
Excellent. So we're just a little bit over time, but only by a few minutes. So we'll end the broadcast there. Take care, everyone, and have a good rest of your afternoon.